Hello everyone, are you ready for a roll down statistics lane? We're going to move on to another part of discrete probability, and in particular binomial probabilities, and even more particular how you can use your calculator. Your TI-84 is what I'm focusing on to find those binomial probabilities. The TI-84 can't do everything, but it's pretty darn good with binomial probabilities. So let's take a look at what you can do. Not too many slides, this won't be too long. So hang in there, turn your calculator on, hit the unpause button, and let's go. So you've got two main functions inside the TI-84. Both of these are binomials, you can tell by the beginning of the word. And this one's PDF, this one's CDF. Those are the two functions. And the first one, remember the PDF, look for the word exact. If you're looking for exactly X, whatever the result is you're looking for, maybe heads, then you need a binomial PDF. If you want some kind of inequality, say more than this or less than this or between these, you want to use the CDF version of the binomial functions. You need three things. You need how many times you're going to do this experiment, what the probability is on each one, and of course, for binomial probabilities, they have to stay the same from one experiment or one trial to the next. And third, you need the number that you're really interested in. Is it something about shooting and making 12 baskets or 3 successes, whatever it is? You need those three: number of trials, the probability on each one, and what you're focusing on. Excuse me. And this is how you do it. So this is the exact one. This is the one that's accumulation. And really, this CDF is a combination of several of these PDFs put together. You could do everything with PDF. However, excuse me, CDF allows you to do 3 or 4 or 5 or 17 of these PDFs at one time and have them added together. That's why it's called cumulative density probability. So both of those can be found on the TI-84. Whichever TI-84 you have, you can use the second function and press the bars key. It'll take you to the distribution function, which is what second bars actually takes you to. And then you can choose binomial PDF or binomial CDF, depending on what you need to do. Now the trick to getting there too is once you get to this distribution function, if you hit the up arrow key, you can get to the bottom of this list. You can see right here, this list only shows from 5 upward. What you want is down at the bottom, and there are a whole lot more than this, but you want to get to this point. The easiest way to get there is hit the up arrow first, and then you'll see binomial, PDF, CDF, and a bunch of others. So here's a question we can attack. So Nathan makes 60% of his free throw attempts. He shoots 12. What's the probability he makes? 10. So let's line this up. How many trials? We're making 12 free throws. What's the probability on each one? 0.6. Or you can put a 0 there if you like. And what we're targeting is getting exactly 10. Also make a note, because It says exactly. That's why we're going to PDF versus CDF. To do that, you're going to use the PDF because we want exactly 10. And so you go to second, bars, or distribution, up arrow until you get to binomial PDF. Enter 12 for N, 0.6 for P, 10 for X, hit enter, and you should get this probability. If you haven't done it before or only have done it a couple of times, it's a good idea to run through this. Hit pause, go through it. It just takes a few seconds because you need to be familiar with going through this. We're going to use that particular distribution menu quite a few times from now till the end of the semester. Next, a little bit different. We've still got Nathan shooting 60%. He's going to shoot 12 free throws just as before. This time it's different. It says less than 10. Now here's the key. First of all, and this sounds trivial, but this will keep you from making mistakes. Make a list of how many free throws he could make if he tries 12 of them. So make a list. He might make none at all. Bad day for Nathan, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's this list for? We'll go up here. What are we interested in? Less than 10. So what we want is 0 through 9. One way we can do that is do PDF for 0, PDF for 1, PDF for 2, all the way up through 9, and add all those results. However, CDF saves us a load of time. So we want, binomial, CDF, because we want a bunch of PDFs added together, and got 12 throws. The probability in each one is 0.6 or 0.6 or 0.60 if you like. And the number we're interested in is we want everything up through 9. We don't want 10 because this says less than 10. So we want up through 9. Now, one thing to remember about this particular function, it always starts at 0. Adds PDFs up to the X value. It always starts at 0. Very important, because sometimes what you want doesn't start at 0 and you have to do some juggling around. By drawing this picture, you can get a better idea of what you're going to have to do with CDF to actually end up with what you want. And I think we'll get an example of that. And if at some point you get confused again, either watch the video again or give me a short email or check with me in the office or in class. So there you go. 12 throws, 60% on each one. They're independent of each other, remember. And we want all those PDFs added together up through 9. We only want the ones that are less than 10. And that picture helps us make sure we're doing the right thing. Next, another twist on it. Again, 60% on each free throw. again, shooting 12 free throws, but now makes at least or at most 10. So we'll make our list. Now I can make this list just like you can. What I'm going to do is I'm going to make a little bit of a shortcut, one that I make. Now notice that 12 is important, so I need 0 through 12. Those are important numbers. Also, it says at most 10, so there's something important about the number 10. And since 10 is important, I'm going to put the number after it and the number before it. Now, if I had 50 numbers, this might be handy. Always put 0 in, first 2 or 3, put the last one in, and then put the item or number of interest plus the one after it and the one before it. Now we'll take a look at it. It says at most 10. So this time 10 is included and everything less than 10. So this time we'll be circling all those. Now this is handy if we were talking about shooting 112 free throws and we still wanted at most 10. We wouldn't actually want to put all those numbers down on our paper, but we want to get it right too. So start at 0, put the first several in, put the last 1 or 2 in, and then the number of interest before and after, and then write down what we're interested in. Now, the way the calculator works, remember, is it starts at 0 and goes up to where you want it to stop. We want it to stop exactly at 10. So we're going to use binomial CDF because we don't want to add all those up by ourselves. We're going to have 12 free throws. We have a probability of 0.6, and we wanted to keep adding those PDFs until it hits 10. There's our answer. Hope you got the same thing. Next, another take on it, still 60%. That way we're working with mostly the same thing, 12 free throws again. This time we want the probability makes more than 10. So here's my plan. I'll start with 0, 1, 2. I know that he can't make more than 12 free throws if he only tries 12. So I'll put 12 there. Maybe I'll put 11 there. Now 10 is our item of interest. So I'm going to make sure I have a 10 here. I already have 11. Put a 9 there. And then ask myself, okay, which ones am I interested in? More than 10. So I don't want 10. I do want 11. I do want 12. And that's as far as it goes. So I want those two right there. On this one, you actually have two choices. You could get the PDF for 11 and the PDF for 12, add them together, and you get your answer. But I want to show you a more clever way of doing it, just in case it isn't quite so simple. So if you want these, remember that all these probabilities added up together, the sum of all those probabilities is always 1, because it's a probability distribution. So if I take the probability of 1 and subtract everything all the way up to 10, I'll be left with 11 and 12. So I'll have binomial CDF, and I'm going to subtract out 0 through 10. So there's my 12 free throws. 0.6, and I want to add all of the first 11 items, 0 through 10. That'll leave me with the probability of 11 or 12. That's very handy. Don't make a mistake and lose that. So here we go. It's exactly what I told you. And a little reminder of N, P, and X. And let's see, one more. We've got a 60% shooter in Nathan again. He's going to shoot 12 times. We want the probability he makes more than 10. So here we go. 0, 1, 2. I want a 10 in here somewhere. It only goes up to 12. Since this is the number of interest, I'll get the one before it and the one after it. Whether there are any in here doesn't make any difference to me. I want the beginning, I want the end, I want the item of interest, and the one before and after it. And then I'll ask myself, if necessary, one piece at a time, what does more than 10 mean? Well, I go to my point of interest here. 10 isn't one of those numbers. It's not more than 10. I could even do something like this. Just as a reminder, what is more than 10? Well, 11 is more than 10, and all the way up to 12. So I want 1 minus all the ones up through 10. Binomial CDF, 12 free throws, 0.6 probability, and I want to subtract out all the probabilities up through and including 10. And there's our answer. Well, I hope you feel comfortable with it now. I'll come back later and we'll talk about something other than using the TI-84 or something similar for doing these calculations. You've got a TI Inspire. You can do it basically a similar way. You can have 1 minus and then go into the menu, statistics or distributions rather, and get my binomial CDF. Do it the same way. You just have a menu instead of having to do it like the TI-4 does it. Okay, see you next time.